Hello everyone, now going to solve Cambridge IGCSE Physics, February-March 2025, paper 4-2. Number 1. Figure 1.1 shows the force extension graph for a spring. A. Calculate the spring constant K of the spring. So, in theory, we know that force is equal to spring constant K multiplied by extension. And you can see the force is in y-axis and extension is in x-axis. So if we find the gradient, we get the spring constant. So let us take a point, right? So this is the origin, passes through the origin, and another point could be this one. And we can find the gradient of it. So it's just 2000 divided by 0.04, which is going to be 50,000. And the unit is going to be newtons per meter. Because it's here, newtons per meter. Okay, B. A student states that the spring has now reached the limit of proportionality when a force of 4,500 newtons applied to it. State how the graph shows that this statement is true. So, reaching the limit of proportionality means that this whole relationship thing, it's not linear anymore. It's not going to be a straight line anymore. It will have a curve at some point when the extension is getting too big because it has gone over the limit of proportionality. So in here it's 4,500 and this is still a straight line. So it shows that this is still in a linear relationship. So this statement is true. So we can write something like the graph is still a straight line at 4,500 newtons. C. Springs can be compressed by forces. The spring described by figure 1.1 is compressed by a force F and has an extension of negative 0.025 meters. Determine F. Negative 0.025 would be somewhere around here, since this is 0.03. And we have to look at the intersection point, and this is right here. You have to know that this is negative 1,000 and negative 2,000 right here. And if you look at the graph, it is about 1250. So we can write negative 1250 newtons from the graph. And if you round that to two significant figures, you get 1,300 newtons. T. State whether force is a scalar quantity or a vector quantity and explain your answer. So force is a vector quantity because it has both direction and magnitude. It's a vector quantity since it has both direction and magnitude. Two, trolley A and trolley B are on a horizontal frictionless bench. Trolley A moves to the right with a constant velocity u 0.44 meters per second, and trolley B is stationary. Figure 2.1 shows trolley A before it collides with trolley B. A. State the momentum of trolley B before the collision. Explain your answer. So it says it is stationary, which means there is no velocity, and momentum is the product of mass and velocity. So it is 0. It is stationary. Oh wait, sorry, it says state the momentum first. So 0 kilograms meter per second, and explanation is momentum is equal to mass into velocity, and B is stationary. V is equal to 0. B. After the collision, the two trolleys are joined together and travel with a constant velocity. V is equal to 0.18 meters per second to the right. The mass of trolley A is 0.75 kilograms. Calculate the mass of trolley B. So this applies the rule of conservation of momentum, which means that total momentum before collision is equal to total momentum after collision. So as we said, right, momentum is just mass into velocity. So we write 0.75 into 0.18. Oh wait, sorry, this is for before the collision, so we have to take the this initial velocity, 0.75 into 0.44 is equal to mass 0.75, and the mass that we're looking for, m, into the velocity 0.18. So you can get m is equal to 0.75 to 0.44 divided by 0.18 subtracted by 0.75. So if you use the calculator, you will get 1.0833 and so on. That is, so you can take two significant figures, 1.1 kilograms. C1. The trolleys move onto a rough surface which exerts a constant force F on the trolleys and brings them to rest in 2.6 seconds. Calculate F. So if they're moving and then they're brought into rest, which means there is a change in momentum. So change in momentum is just from, so here's the total momentum, sorry, not this one. So here's the total momentum, right? And that will become 0. So the change in momentum is this itself. So let's just write an equation first. F is equal to change in momentum divided by time. So F is equal to 0.75 plus 1.1 into 0.18 divided by 2.6. So if you use a calculator, you get something like 0.128 and so on. And if you take the two significant figures, you get 0.13 newtons. To a different rough surface exerts a smaller resistive force on the trolleys. State how this affects the time taken to bring the trolleys to rest. Explain your answer. So you have this equation written here, and if the force is less, you can see that this is inversely proportional to time, so time will increase. And you have to note that in this equation, this change in momentum will be constant. So we can write time taken increases. So according to F is equal to change in momentum divided by time taken, force is inversely proportional to time. Okay, so figure 3.1 shows a mains electric heater used to heat a small room. A, state the region of the electromagnetic spectrum which radiates thermal energy from the heater. So it is infrared radiation. So if it's hot and like hot things, most of the objects, or almost all the objects, they emit infrared radiation because of the heat. B, explain why the shiny metal surface behind the heating elements increases the thermal energy radiated into the room. So shiny metal surface, they're good reflectors. So they kind of reflect the radiation into the room. So you can write shiny surface is a good reflector of thermal radiation. Which makes the room warmer. C, the metal outer casing of the heater is earthed. State why this is an important safety feature. So earthing, it kind of prevents the electric shock. So if the live wire is touching like this metal case, because metal is can conduct electricity, right? So if the live wire touches it, it will conduct to you, and it is very dangerous for human. So instead, the earth wire, it will take the charges instead and then conduct to the ground, and it won't harm you anymore. So we can write something like earthing prevents electric shock if the live wire touches the metal casing which conducts electricity. D, the mains voltage is 230 volts. The two identical heating elements are connected in parallel. Each heating element has a resistance of 89 ohms. 1. Calculate the current in one heating element. So it says they're connected in parallel, which means that the voltage will be the same throughout the parallel circuit, but the current will not be will have to be shared. But it just asks for one heating element, doesn't really matter. You can just write V is equal to I in R, and I is equal to 230 divided by 89. And that is 2.58 something. 584. Take two significant figures, 2.6 amperes. To show that the electrical power of the heater is approximately 1200 watts, state any equation you use in words or symbols. So power is equal to current into voltage, and this heater will have two heating elements, so we can multiply that by 2. I is 2.6, V is 230, and you can get 2 into 2.6 into 230 is about 1196 watts, which is approximately equal to 1200 watts. 3. The heater is 95% efficient as converting electrical work done to thermal energy. Calculating the thermal energy emitted by the heater in D2 in 60 seconds. Give your answer to two significant figures. So which means that this is the input energy, right? So total input energy. And it is only 95% efficient, which means that you have to calculate for total output. useful output energy as well. So let's just write the equation for efficiency, right? Efficiency is equal to useful energy output divided by total input energy. And since it is 95%, which is 95 divided by 100, is equal to like output, which is emitted, right? And this is we are calculating in energy, which means we have to change this power into energy as well. So P is equal to E by T, right? So 1200 will be equal to energy multiplied by time. Time is 60 seconds. So you get energy is actually 72,000 joules. So we have to put that there. 72,000. 0.95 into 72,000 is 68,400 joules. So we can just write this and take two significant figures. You get 68,000 joules. For a train has a maximum speed of 200 kilometers per hour. It accelerates from rest with constant acceleration of 0.70 meters per second squared. 8.1. Define acceleration. Acceleration is rate of change of velocity. It has to be velocity because it is acceleration, right? So show that the maximum speed of train is approximately 56 meters per second. So maximum speed, it is 200 kilometers per hour, and we have to convert that to meters per second. So we will write something like this. This is kilometer per 1 hour, and we want meters, so we will multiply that by 1000, and we want seconds, so we will multiply that by 3000. Okay, so let's just go step by step, right? Minutes, seconds, right? And so you don't need you don't need to write these. Technically it could be wrong if you write like that, but it's just more obvious that way. So 200 to 1000 divided by 3600, you get 55.55, so on, and this is approximately equal to 56 meters per second. To calculate the time taken for the train to reach its maximum speed, so here is the acceleration, right? So V, this is final velocity, right? V is equal to acceleration to time taken, and T will be equal to maximum speed 56, 0.70, which is 80 seconds. V1. The train has a total mass of 440,000 kilograms. Calculate the force which causes the acceleration of the train. So force, acceleration, mass, you have this equation, F is equal to ma, and mass is, let's just try 4.4 into 10 power 5 into acceleration is 0.7 into to 0.7 is 308,000. So this is approximately equal to 3.1 into 10 power. Okay, I will just write in the final answer. Newtons. 3.1 into 10 power 1, 2, 3, 4. 10 power. Wait, 1, 2, 3, 4. Oh wait, I forgot 1 0. 10 power 5 newtons. 2. The train travels into a headwind. The force of this headwind opposes the motion of the train. State and explain the effect of this force on the motion of the train. So a headwind, I just think it's some kind of resistance wind, right? Don't exactly need to know, but yeah. So since there is resistance acting on it, the resultant force will decrease, and if this decreases, the acceleration will also decrease. So you can say that statement is motion, like the train becomes like slower, reduced acceleration, and the explanation is because resultant force, which gives acceleration, decreases. 5. A light dependent resistor LDR has a low resistance in high light intensity and a high resistance in the dark. That gives the information that you should already know. Sketch a graph of resistance y-axis against light intensity x-axis for an LDR. So y-axis resistance ohm and light intensity is okay. Light intensity is units is CD, right? But it's not required. It's not in the syllabus. It just wants to test you about how this graph thing, that they exist, don't really matter in this case. So it here says they're inversely proportional. I mean, not linear proportional, but if one increases, the other decreases. So as light intensity increases, the resistance will decrease. So we'll have some kind of negative graph thingy, right? Negative gradient. So it goes something like this. B. Figure 5.1 shows part of the electric circuit used to turn on a light when it is dark. 1. Complete the circuit in figure 5.1 with a symbol for a light-dependent resistor LDR. So light-dependent resistor looks something like this. It is a resistor, first of all, a rectangle. Because it is light, you will have some light going on here. To explain why the lamp is off in the light and lamp is on in the dark, use ideas about potential difference in your answer. So when the lamp is when the light is in low intensity, right? It is dark, then the resistance will increase. So the resistance of here will increase. And if resistance increases, it gets a higher proportion of potential difference from the circuit. And so and the lamp is connected in parallel series with the LDR, so it also has a higher proportion of voltage. So you have to know that this connection, this one item and this one item, they are in series circuit, which means that the current is the same in both of them, but the voltage will be potential difference will be shared. So as I said, as it is in the dark, light intensity decreases, the resistance will increase, and according to V is equal to IR, where I is constant, if resistance increases, voltage increases. And because they are in parallel connection, they get the same voltage, right? So this voltage will also increase. So you have to write that thing out. So you can say first is something like in low light intensity, the resistance of LDR is high, so it will get a higher portion of voltage. EMF. As it is shared with fixed resistor. So they are in what? Series connection. Since the lamp and LDR are in parallel connection, they get the same amount of EMF. So since EMF for LDR increases, the lamp also gets high EMF and it lights up. Figure 6.1 shows an object O, which is 5.0 centimeters away from the center of its thin converging lens L. The focal length of L is 3.0 centimeters, and the figure is drawn to full scale. Okay, so label the principal axis with P. So this is the P. Place letter X at a focal point. So the thing is, right, focal length is 3 centimeters. So focal point is the distance between this center of the lens to the focal point. So since I don't have a ruler here, I can't really do that. And what I know is that this is 5 centimeters away, so 3 has to be somewhere here. This has to be focal point. You have to do it accurately though. And figure 6.1, draw 2 rays from O to locate the tip of the image produced by the lens. Okay. So 2 rays. Image produced by the lens. So firstly you get to this point, and focal point will also be here, right? This is 3 centimeters, and you get to this here. Light rays, you have to put the arrows, that's important, and something like this, right? So in theory, this is between F and 2F will be somewhere around here. So it will appear beyond 2F with enlarged image. So yeah. Okay, so that's just what I just described. In figure 6.1, place a tick in the right hand column next to all the terms that describe the image in A3. So will be enlarged. Since it is real image, it will be inverted as well. B, the object moves closer to L. This is L, yeah, lens. The new distance between L and the object is less than the focal length of L, which means that it is between center of the lens and the focus, which means it will produce a magnified image. It will work as a magnifying glass. So describe how the new image is different from the image just above. So it is a magnifying glass. It will produce the image is virtual. Will produce a virtual image, which is upright. Figure 7.1 is a scale drawing of light waves approaching a narrow slit. So looking at the diagram, it will ask you about diffraction, right? So 1, name the wave effect produced by the narrow slit diffraction. Using figure 7.1, determine the wavelength of the light. Give your answer to 2 significant figures. So here is the wavelength scale, and you've got, this is the one wavelength, right? You have to measure it, and let's say it has like 1 centimeter. So the wavelength will be this much, and if it is like, say 0.5 centimeters, then it will be like 2.7 to the power minus 7, right? Depends on what you can measure. Since I don't have the ruler here, can't really do that. So use the scale and find the wavelength. 3. On figure 7.1, draw 3 wavefronts that have passed through the narrow slit. So you have to measure this gap as well. So if this gap and the wavelength approximate they equal, then it will have like a semicircular thing. Like the wavelength has to be approximately equal to here, and it says 3. Like this one becomes too big. It will look something like this because these two sizes they're approximately equal. Or this is bigger, the diffraction will happen. B. A foghorn emits a sound with frequency 380 Hz. The sound is heard by a ship 2.5 kilometers away from the foghorn. The speed of sound in air is 330 meters per second. 1. Show the wavelength of the sound is approximately 0.9 meters, and say any equations you use in words or symbols. So I have to use the wave equation. V is equal to F lambda. Lambda wavelength is equal to V by F, but you don't really have to write this. So V is 330 and F is 380. Divided by 0, you get 0.868 for so on, and that is approximately equal to 0.9 meters. So calculate the time it takes for sound to travel to the ship from the foghorn. So time taken, V is equal to distance by time, and distance is 2.5 kilometers, but we have the unit in meters per second, so we will change that to 2,500 divided by 330. And you get 7.575 and so on. Get 7.6 seconds. 8. Figure 8.1 shows a metal rod suspended in the magnetic field produced by a pair of permanent magnets. The metal rod is connected to a cell, and there's a current in the metal rod. A. State the direction of the force on the metal rod due to the current. Direction of force and explanation. So this is you have to use the Fleming's right or left hand rule. We'll figure that out. Thing is, you already have the magnetic field, and it is going from north to south, and there is current Okay, so current is from positive to negative, so it will go something like this. So you have to think about whether to use left or right. So since there is current and there is magnetic field, it will produce a force, and the direction of force is given by Fleming's left hand rule. So So firstly, let us think about the directions, right? So magnetic field direction will be from left to right because north to south. And the right direction of current is from positive to negative, so we'll go something into the page. So whether to use left hand rule or right hand rule, we know that it is asking for the direction of force because of the already existing current. Then we use the left hand rule. So your finger should be pointing to the left and your middle finger pointing into the page, and you will see that your thumb will be pointing downwards. So the direction of force will be downwards. An explanation is that the directions of current, force, and magnetic field are mutually perpendicular to each other. According to Fleming's left-hand rule, when the direction of current is into the page and the direction of magnetic field is from left to right, the direction of force is downwards. The connections to the cell are reversed. State how this change affects the force on the metal rod, and the direction of force will reverse, right? So direction of force will reverse. Two magnets and a cell are used to make a simple electric motor, as shown in figure 8.2. Describe the function of parts J, K, L, and M. So J is carbon brush, and it conducts electricity to the circuit cell. And K is coil, which rotates, and current flows through it. And L is axle, and it allows the coil to turn. And M is split ring commutator, which reverses the direction of current every 180 turn. 100 degrees turn. 9. Strontium-90 is a radioactive isotope of strontium. The nuclear notation for strontium-90 is this right here. In A1, explain what isotopes are. So isotopes are atoms, different atoms of the same element with same number of protons but different number of neutrons. So we write different atoms of the same element with same number of protons but different number of electrons. To complete table 9.1 for strontium-90, so particle number in one atom, 38, has to be, here is its location outside of the nucleus, so electron, and number in one atom, 90 minus 38, that is 52, and location is inside the nucleus. And here is proton. B. Strontium-90 is used to measure the thickness of metal sheets in industry. Strontium-90 decays by emitting beta particles which pass through a metal sheet to a detector. One metal sheet is 0.75 millimeters thick. Suggest why strontium-90 is a suitable radioactive source to measure the thickness of the metal sheets. So essentially it is just because it emits beta particles. So beta particles, they can pass through this thickness of 0.75 millimeters, and you can like adjust, right? If the material is at the right thickness, there will be a certain amount of beta particles passing through. So you know that if the beta particles amount is less than expected, then it is like thicker than expected. Or if there are more beta particles than expected, then it will be thinner than the actual thickness. So you can kind of get this idea from using the strontium-90. So you can write something like beta particles can penetrate through 0.75 millimeters of metal, and the amount of emission is affected by the thickness of the metal, so that it can be known whether the metal is at the right thickness or not. To the half-life of strontium-90 is approximately 27 years. Figure 9.1 shows the shape of the decay curve. Strontium-90 source is replaced with another source after 15 years. Using figure 9.1 suggests why a strontium-90 source that is more than 15 years old needs to be replaced with a new source. So after 15 years, right, the percentage kind of decreases, but the half-life is right here, right, approximately 27. So after 15 years, right, the range is kind of like decreasing, which means that the beta particles emitted will decrease. So you can't really adjust with this fact anymore. So the count rate will be like too low. When it is too low, you can't really expect can you predict the thickness of the metal accurately anymore. So you can say something like after 15 years, the amount of beta particles emitted will be around 60 to 78%. And let's just write for 75 and getting lower. So the count rate decreases and becomes too low to compare. 10. Figure 10.1 shows the path of the Earth as it orbits the Sun. X is the position on the Earth where scientists observe the apparent motion of the Sun throughout the year. 8. Determine how many days it takes the Earth to move around its orbit from F to G. Explain your answer. So here from F to G, it's like 1, 2, 3, 4. It's like 1/4 of like this whole orbit, which means that this whole orbit we know that it takes 365 days, and divided by 4 we get 91.25 days. So we can just write 91 days. So F to G is 1/4 of the complete orbit, which takes 365 days. The figure 10.1 shows 4 positions E, F, G, H of the Earth in its orbit of the Sun. Identify the position of the Earth when it is summer at X. So the Earth is tilted, and that is why we get seasons, right? So if it is like nearer the Sun, it will be summer. So right here, when it is summer at X at the northern hemisphere, which means this is like closest to the Sun, right? So you can write F and write it X. No, it's not. And yeah, so it is F. When it is winter, which means that it will be the furthest from the Sun. So not here. No, it is not here as well. And now this is like, yeah, farthest away from the Sun. So you look at the tilt of the Earth and whether it is close to the Sun or not. If it is farthest, then it will be winter. If it's the closest, then it will be summer. So you get H. C. The orbital speed of the Earth around the Sun is approximately 3.0 into 10 power 4 meters per second. Calculate the average radius of the Earth's orbit. So we have this equation, right? So orbital speed is equal to the distance, right? Distance of the orbit, 2 pi r by t. And for t, we know that it is 365 days and 24 hours a day, and then 3,600 seconds. And 2 pi r is here. Oh, sorry, we have to find the r. That is v to times 4. So we can calculate r. 2 times 4 into 365, 24, 3,600, then 2 pi. You get 1.505 something, 05 something to 10 power 11. So we can write 1.5 into 10 power 11 meters. D. Earth is a planet in the solar system. Say one other type of naturally occurring object that is present in the solar system. So like the most obvious one is probably Moon, right? Like it is orbiting the other planets. So you can write asteroids, comets, those kind of things as well. So Moon is also one of the natural satellites, right? Yeah. So this is the end of the paper, and go back with your studies.